Alright guys, welcome to your 20th physics video, and in this video I want to talk to you guys and show you an example of the conservation of momentum. So let me go ahead and show you guys the famous cart example. So say that you have two carts, cart A and cart B. Now it would probably make more sense if I actually added wheels to these things. So just imagine that these are big blocks of wood on wheels. So cart A and B are identical to each other, both in size, mass, all that good stuff. However, they are connected by a spring. Now this is a pretty powerful spring, and what this spring wants to do is push A away from B. It just wants to expand and separate the two. However, well, let me go ahead and label this so you guys can actually tell what I'm drawing. However, the reason that the spring isn't pushing these apart is because these two carts are held together with a rope. And I guess I better label this too. Rope. Just like that. This drawing is actually one of my better drawings. So let's go ahead and take a few calculations here. First of all, we know the total force of the system is zero. That's because force equals mass times acceleration. And if you take the mass of all of this, well, it wouldn't really matter because nothing is accelerating. Therefore, the force is zero. Okay, we already know that. But the new thing that we learned is the momentum is also zero, because momentum we know is equal to mass times velocity. So if you go ahead and say that this is actually one big object and it took the mass of it, well, the mass doesn't even matter because this system, nothing is going anywhere. It has a velocity of zero. And of course, you know, no matter what the mass is, whenever you multiply something by zero, the answer is always zero. So no matter how massive these carts are, since the velocity is zero, that means the momentum must also be zero. So what we're going to do is we are now going to take a pair of scissors, let me get it out right here, and we are going to cut the rope. Now as soon as we cut the rope, cart B is going to go flying in this direction, and cart A, let me draw my arrow a little better, is going to move in this direction. Why? Because the spring is going to push both of those things apart. Now, of course, this is, cool, and we could build this and watch it fling apart, but what's the point? Well, the point is to demonstrate the conservation of momentum. Now, the conservation of momentum in this example pretty much says, since the momentum of the total system before we cut the rope was zero, this means after the carts, pretty much before we cut the rope it was zero, after we cut the rope it's zero. So if you're saying, okay, wait a minute, you're telling me that now that these carts are moving, they both have a mass and they have a velocity, and momentum is still zero? How the heck does that work? Well, let me go ahead and explain. It may be a little bit easier to understand if we gave these carts values. So let's go ahead and give them both a mass of, 10 kilograms and 10 kilograms. And we'll say that once that rope was cut, they started moving at, 5 meters per second. So 5 meters per second to the left, and this one started moving 5 meters per second to the right. Now check this out. The momentum, of cart A is equal to the momentum of cart B. The only thing is that it's in an opposite direction. So of course, if we figured out the momentum of this, it would be 50, and if we figured out the momentum of cart B, it would also be 50. But even though they have the same momentum, they are moving in opposite directions, so the total momentum of the entire system as a whole is still zero. So that is how we know that the conservation of momentum is indeed a valid law, because it pretty much says this. And I think this is the formula law, that the total momentum in any system is equal before and after any event. And whenever they write this, they always write the event in quotation marks for some reason. So again, that's law. I'm going to say it one more time because that's what I have to pound in your brain. The total momentum in any system is equal before and after the event. So basically in this example, when the carts weren't moving at all and the rope was intact, we figured out that the momentum was 0, and after the rope was cut, and each of these carts had a momentum of 50, but they were in opposite directions, that's what also caused the momentum of the entire system to be 0 after the event. And of course, the event in this case was the cutting of the rope. So that is basically the conservation of momentum. In the next tutorial, I'm going to give you guys an even better example, which is probably more useful than cutting ropes and stuff. So anyways, thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video.